Hi students, this is Mr. Yao. Today we are going to talk about 8.3, where we will learn the last kind of conic sections, which is parabola. And of course we have learned about parabola before in Unit 4, where we talk about quadratics, but this is parabola more in the sense, in a connection with conics sections. But first, let's still review what we have learned before. What was the, it's actually asking for the vertex form, not the standard form. That's a typo in the was the vertex form of a quadratic function? It is right here. A times x minus h inside parentheses, then square it, and plus k. And of course, the h and k would be the vertex. The a represents how wide our parabola opens. Because a is about if it's stretching or shrinking. You remember when we learned about the transformation for these functions, that's what we have learned. Now moving on to today's lesson, we are going to define parabola kind of in a different way. So here's a link if you want to see how parabola works. In this lesson, we're going to define parabola using conics, which will involve a special point we have learned in ellipse, which is the focus. So if you recall, encircle one fixed point and a fixed length. And when we got to ellipse, we have two fixed points and a length and some, actually. And then we got to hyperbola, so two fixed points, but that instead of the sum, it was the difference. And lastly, today's lesson, of course, is going to be parabola. Parabola is the set of points on a plane that are equal distance from a given point and a given line. So this time we have a given point and a given line. The given point is called a focus, and a given line is called the directrix. So it's basic. Here's the basic idea. We have a point, we have a line. It's basically, well, let's say midpoint or here, and the same distance, we got a point here, same distance, we got a point here, and we kind of connect it around, and we are going to get a parabola. That's kind of the basic idea. And again, if you want to have a look, here's the link where you can check out how this parabola is actually formed by the fixed point and the fixed line. Moving on. First, let's start with a vertex at 0, 0. This is the case, 0, 0. The equation looks slightly different. Y equals 1 over 4p times x squared. I'm trying to show you it's a format that's similar to what we have learned before, the vertex form, which would be like ax squared. Or in the more common one in this lesson is going to be 4p times y equals x squared. We are going to keep the 4p on the left side. I'll explain where does this number p come from in a bit. So let's start with the point 0p. Since we have a fixed point and a fixed line, we got to start with them. So let's say this is our fixed point 0p, which is the focus. So I'm just going to use letter F. And of course, we have this line y equals negative p. Based on the definition, the vertex will always be halfway between the focus and the directrix. So here's why. The vertex is right in between. It's that part of this, that distance and this distance, they will be the same. So the vertex is basically the midpoint of the focus and this point on the directrix. And they are both p away from the vertex. Or in other words, the distance from the vertex to the focus and the directrix would always be p. That's why the focus will always be inside the curvature. So when you have this curve, or when you know the focus is right here, the direction is over is down there, you will know the curve is actually facing up because it's got to include that focus inside. It will never cross the directrix. Now let's talk about the point P. P is related to A in our quadratic form, which is right here. So it was A, now it's actually 1 over 4p. So there is this relationship. P is 1 over 4a, or A is 1 over 4p. As for the reason why it is 4p, here's the reason. Draw a line across the focus. This is called a focal chord. the length of that focal chord is exactly 4p. So on the left side we have 2p, on the right side we have 2p, so together it's exactly 4p. And that's kind of relationship between how wide the whole thing is using letter p. And since a also represents how wide it is, there's a relationship 1 over 4a or 1 over 4p for p and a, because p and a are both representing how wide the parabola opens. So there's our relationship for vertex at 0, 0. Now let's talk about when the vertex is not at 0, 0, it is at hk. There shouldn't actually be a y-axis here. Just imagine there's no y in there. We are just starting with a random point hk for the vertex. Here are the formulas, and that I'm going to write down the original form we have learned: a times x minus h squared plus k. As you can see, the x minus h squared part stays the same, the k part stays the same. The only part that's different is the a changing into a 1 over 4p. Then, of course, we can choose to subtract the k on both sides, so we got y minus k. Then we're going to multiply both sides by the 4p. That gives us the more general equation, or a function or equation for parabola in conics. Now, same thing. Let's talk about where these things are. Vertex is at hk, and p is still the distance from the vertex to the focus and to the directrix. So let's draw that out. Let's say this is our focus right here, and this part would represent the p. And then we need also p away to actually get our directrix. As for what these lines are, let's think about it. It is, of course, vertical, so the h does not matter. It's the k that we need. If this part of the length is already k, and this part is a p, well, that means this point is basically at k plus p as a y coordinate. The x coordinate is still h because it's on the same vertical line. If that part is k and vertex is p away from the directrix, that means this little portion would just be p minus k. I mean k minus p. K minus p. Because it's not just that little portion. This is actually the coordinate of this point. Because at this height is a k, we're going to subtract p to get to the directrix. So that is why the directrix is y equals k minus p. So either way, you may notice we are going to need to start with a vertex and then find our p so we can generate our focus and our directrix. Next, when p is greater than 0, or in other words, when a is greater than 0, of course, is opening up. That also means the directrix is going to be below the vertex and the focus is going to be above the vertex. When p is less than 0, of course, that means a is less than 0. Then it's actually going to be the other way, focus here and the directrix above. Now let's have a look at a few examples. Example 1 and 2. Find the equation of the parabola with the given information and represent the information and equation on the graph. So first, let's draw 0, 7. That's our focus. F0, 7. The directrix is y equals -7, which is down here. If you recall what we just talked about, the vertex is the same distance to the focus and the same distance to the directrix. Basically, in other words, the vertex is the midpoint or halfway between the focus and the directrix. Focus is at 7 as a y, and the directrix is at -7, so of course my vertex would be 0, 0. That is my vertex. Now, we are not going to draw super precisely how wide it is opening. We are just going to use kind of the information that we are given and kind of do a sketch. We already know it's going to have the focus inside the curvature, so it's going to be facing up. So there is our parabola for example 1. Next, example 2. My focus is at 3, 3. That is my focus, 3, 3. My directrix is actually at y equals 7. In that case, you can see they are 1, 2, 3, 4 away from each other. So of course, halfway will be 2. So this is my vertex, which is 3, 5. Since our curve needs to include a focus getting away from the directrix, it is going to be facing down. just a general shape. There we go. That is example 2. Moving on, the vertex is 10 and 2. The directrix is y equals 25 over 12. So in this case, let's draw the things. We don't have a graph, at least on here, but you can choose to draw it on the shape, on the graph, on your paper. But 25 over 12 is not the easiest point to identify. So let's kind of just do a rough idea. So the vertex is at 10, 2. Let's say that's the vertex 10, 2. The directrix is at 25 over 12. So with that is our vertex. We already know that our focus is going to be somewhere down here. And this is P. And since it is a vertical kind of setup, we are basically looking for how far away is the 2 compared to the 25 over 12. So all you need to do is 25 over 12 minus the 2. And that is going to give you the P, because the distance between the directrix and the vertex is going to be P. P in this case is 1 over 12. Now we can write down the formula, the equation. I'm going to put it up here. 4P y plus, not y, plus y minus k equals x minus h squared. So hopefully you're going to kind of get used to the formula so you can just set it up. P is 1 over 12, so we need 4p, so 4 times 1 over 12. And then 1 minus y minus, my k is going to be the y value for the vertex, so 2 equals to x minus 10 squared. 4 times 1/3 is, 112 is actually 1/3. Y minus 2 equals x minus 10 squared. We don't need to simplify it or anything. We can just keep it in that format. Example 4. Vertex and focus. Let's say this is our vertex, -4, 8. And our focus is actually right here, -4, 65 over 8. And now we don't actually need the directrix, because the distance between the vertex and the focus is already a p. So in this case, my p is going to be 65 over 8 minus 8. And that is going to give us 1 over 8. Time to write the equation. 4 times 1 over 8 times, it is y minus 8, because the y coordinate for our vertex is an 8. Squared, not squared, equals to, on the other side we have the square. X is a -4 for the x coordinate, so we're going to do x plus 4, then squared. Of course, we need to simplify the 4 times 1/8. 1/2 y minus 8 equals x plus 4 squared. That is example 4. Moving on, example 5 and 6. This time we are going to base on the equation to determine the vertex, the focus, the directrix, and a direction for each of the parabola. So for this part, I do recommend you drawing a little diagram. It doesn't have to be a whole graph, but I do recommend you to draw a little diagram. Let's start with the vertex. Remember, the vertex is always going to be like x minus something and then the y minus something. So if nothing has changed, it is just x and y. That means my vertex is just 0, 0. Next, whatever number is in front of the y in this lesson are going to be the 4p. So basically that means 4p equals 8. So my p would be a 2. Now that's kind of making things easier to identify. If you recall, well, let's actually draw the diagram. Instead of trying to think, oh, is it k plus p, h minus p, whatever the formula may have been, we are just going to kind of explore and draw a diagram to represent things by ourselves. So vertex is at 0, 0. The whole thing is positive, which means my focus is going to be on the above and my directrix is going to be below. Now, if that point is 0, 0, and we already know p is 2, that means I just need to move up from 0, 0, so it's 0, 2. And because again, this part represents 2, this part represents 2, so basically I will end up being at y equals -2. That is the directrix. So focus is going to be 0, 2. And the directrix is going to be directrix going to be y equals -2. As for the direction, well, the focus is above the vertex, so it is going to open up. That is example 5. Moving on, example 6. Let's start again with the vertex. We're going to use the points next to the x and the y, so the vertex would be -4 and +1. Next, it's time to find our p. Our p is going to be related to this -6 number because it's kind of always attached to y. So that means my p is going to be -6 divided by 4, so -1.5, or actually -3/2. Next, we are going to use our p and the vertex to draw a little diagram. Vertex is at -4, 1. But also because it's -6, that means the whole thing is facing down, so we will have a focus down there and the directrix is above. Next is time to find where the focus is. Because, in case you haven't noticed, everything we're working with are kind of facing up and down, which is why it's going to be a vertical kind of setup. So the x-coordinate wouldn't change, but this y value would change. Because the p is -3/2, that means the vertex to the point, it is going to be 1.5 away. And then the other side, the vertex to the point is going to be 1.5 away. So now 1 minus 1.5 is going to get us to lower in coordinates for the focus. That gives us -4 and -0.5. However, for the directrix, well, it is currently at a 1, but the directrix is above that point, so that means we're going to need to do adding by 0.5. So the whole thing is going to become y equals, so -4, and going up 2.5 from 1 is going to be 1.5. Here it is. The directrix is y equals 1.5. Well, actually not 1.5. I just realized it's 2.5 because it's 1 plus 1.5, so 2.5. Lastly, because the focus is on the bottom, so of course the whole thing is going to be open down. That should cover everything for this first parabola lesson. Thank you.